Hello and welcome to the fifth and the last video in this series of videos on differentiability. Kung mapapansin niyo yung title, tatlo yung nakasulat dyan: differentiability, differentials, and local linear approximation. Na-discuss na natin yung differentiability and local linear approximation. So today we will discuss yung differentials. Okay? We will define what they are, and we will see that we can also use like the tangent plane, like the local linear approximation. We can use these differentials for approximation. Okay? So tandaan lang natin from Math 21, if you are given a differentiable function, y equals f of x, nag-introduce tayo ng panibagong independent variable. No? X is an independent variable, dx is also another independent variable. So yung dx pwede natin mag-input ng kahit sino dyan. No? And what is dy? Yung dy, this is a dependent variable. Okay, so it already depends on the values of dx and x. So ito yung formula natin. No? Dy is defined as f prime of x times dx. And yung application niyan, kasi yung dx natin, sabi natin, pwede nating lagyan niya ng kahit anong number. Pero in applications, usually yung nilalagay nating value for dx is the change in the input. Okay? So halimbawa, yung input mo na x nagbago, no? So from x to x plus delta x, yung change in input na yun yung usually nilalagay natin, pinapasok natin dyan sa dx natin. Okay? So meron na tayong value for x, meron na tayong value for x, meron na tayong value for dx. So mako-compute nyo ngayon yung dy. And usually, this process is not difficult. Madali lang computein yung dy from that. Tapos, nalaman natin from Math 21 na yung kung ano man yung makompute yung dy, that's approximately equal to delta y, which is the actual change in the output. Kapag nagbago yung input mo from x to x plus delta x, syempre magbabago yung output mo from f of x to f of x plus delta x. So, ganun din yung sa function natin of two variables, f of x, y. We can define additional independent variables, yung dx natin, tsaka dy. And yung dz, that's going to be a dependent variable. Kino-compute lang yan. And the formula is given by this. So, dz is the partial derivative of f with respect to x times dx plus the partial derivative of f with respect to y times dy. And it turns out na ang application niyan kamukha rin nung sa one variable case. Okay, if you let dx and dy be small changes in the input x and the input y, yung mako-compute yung value ng dz, that's a good approximation for the actual change in the output. No? So ito yung original input mo, x and y. Ito yung new input, x plus delta x, y plus delta y. So yung delta z is the change in the output. And dz is an approximation. So siguro mas maganda kung may example tayo para makita natin kung ano yung mga sinasabi ko. Halimbawa, let z be equal to tangent inverse xy. Let's compute dz and compare dz with delta z when xy changes from 1, 1 to 0.9, 1.01. So, unti-unti natin na. Una muna, let's focus on computing dz. Ito yung pinakamadaling gawin. Kasi yung dz, very formulaic. So, ang formula for dz ay partial derivative with respect to x times dx plus partial derivative with respect to y times dy. Okay? And kailangan nyo na lang computein itong dalawang to. Tapos yun na yung dz. But what is partial z with respect to x? So anong derivative ng tangent inverse of xy with respect to x? So with respect to x, so ang derivative ng tangent inverse ay 1 over 1 plus the inside function squared. Kasi i-differentiate may inside function with respect to x. So magkakaroon ka ng y. So yung partial z partial x is equal to y over 1 plus x squared y squared. Okay, so ito yung sinasabi ko kanina. Kailangan nyo makuha yung partial derivative with respect to x, tsaka partial derivative with respect to y, and then just multiply those things by dx and dy. So ito yung na-compute natin for the first partial derivative. And similarly, you can check ito yung makakuha nyo. No? Mapapalitan lang yung y sa taas ng x. Yan yung magiging partial with respect to y. So yun na yung unang part, yan yung pag-compute ng dz. Ang isang gagawin naman natin, kailangan nating mag-estimate na ano daw yung value ng dz compared sa actual change in the output. So, kapag binago mo yung input from 1.1 to 0.9 and 1.01, ano mangyayari sa ating output? Okay, so if xy changes from 1.1 to 0.9, 1.01, ibig sabihin, yung delta x natin ay so the new x value minus the old x value. So this is negative 0.1. Okay? Tapos yung delta y is the new y value minus the old y value. So this is 0.01. Okay? Ito yung mga gagamitin nating value for dx and dy. Okay? So, meron tayong x and y. No? Yung x natin ay equal to 1 and y is also equal to 1. Tapos, meron na rin tayong value ng dx, yan yung change. No? So, itong x and y, those are the original input. No? Yung dx and dy, yan yung change in the input. So, negative 0.1 and 0.01. Tapos, pasok nyo lang yan lahat dyan na, para ma-compute natin yung dz. So, ito, yan, pinagin lang natin na yung value ng x, ng y, x and y. Tapos, ito yung dx, saka ito yung dy. So, pag sinolve niyan, lalabas negative 0.045. Okay? So, this is dz. Okay? Pero pag ginamit niyo yung calculator, ano yung totoong change in the output? So, pag tinignan niyo yung tangent inverse of kung ito yung new input niya, so ito yung new output. No? Tapos, ito yung so this is the old output. Kung nandito yung old input. Tapos ito yung new output. Corresponding to the new input here. Okay. Ito, makakompute nyo to using a calculator. Ang lalabas ay itong number na to. So, ito mahirap to computein. No? Kailangan nyo ng calculator dyan. Pero itong dz, madali lang kasi yung x mo, tsaka y, no? Madali lang yan. Mga 1 lang yan. Tapos yung dx and dy, they're not too bad either. Pero, mas madali yung dz, pero pag tinignan nyo, halos kamukha niya yung delta z. So, itong dz is a good approximation for delta z. No? Kung wala kayong calculator, pwede kayong mag-compute ng change in the function value using differentials. Okay. So, ito pa isa, halimbawa, word problem. Tingnan natin na. Let's look at this word problem. So, the legs of a right triangle are measured to be 3 centimeters and 4 centimeters with a maximum error of 0.05 centimeters in each measurement. So, meron daw tayong right triangle. Tapos nung sinukat natin siya, ang lumabas ay 3 cm tsaka 4 cm. Pero syempre, pag nagsusukat kayo na using a ruler, hindi exact yun, no? Kasi yung mga ticks dun sa ruler, merong ano yun, may limit na. So, alam natin na yung totoong value is somewhere between yung true value halimbawa sa side na to ay between 3.95 and 4.05 centimeters. Hindi mo masigurado na dahil hindi fine enough yung ruler mo. Pero alam mo na dapat yung true value is between 3.95 and 4.05. That's the maximum error in your measurement. Dito naman sa side na to, between 2.95 cm and 3.05 cm yung true value. Again, hindi natin alam na. So, gamit daw tayo ng differentials to approximate the maximum possible error nung kinalculate natin yung hypotenuse and the area. Okay? So, it's just, so syempre, kung meron na tayong dalawang side, we can compute for the hypotenuse here, no? And also the area. Okay? So, ano nga ba yung formula nun? So, if x and y are the lengths, and h and capital A are the hypotenuse and the area, by Pythagorean theorem, yung hypotenuse, that's the square root of x squared plus y squared, di ba? Tapos yung area ay just 1/2 times the product of the lengths of the leg. So, x times y. Okay. So, ang goal natin is to estimate the following error. No? Yung worst case na mangyayari, halimbawa, yung worst case ay 3.05 or 2.95 pala talaga isang leg. Saka 4.05 and 3.95 yung kabilang leg. Yung worst possible case, sobrang layo nung nakuha natin. Hindi naman sobrang layo. We got 3 pero ito tong value niya pala ay 3.05 halimbawa. So, ito yung makakalculate nating hypotenuse, pero ito yung totoong hypotenuse. No? So, yung delta H here represents the error in our calculated hypotenuse versus the true hypotenuse. Tapos ito rin, ganun din. No? Kung ito yung nakalculate nating area, kasi 3 and 4 yung nakuha nating measurement. Whereas kung ito yung mga true legs, yung true lengths ng mga legs, okay, kung ito yung totoong area, so yung difference na yan, yun yung error natin. No? This is the measurement error. So, gusto nating i-estimate itong delta H and delta A. Of course, if you have a calculator, pwede nyo namang computein na lang yan. No? Kasi given naman yung H saka capital A. But let's use differentials kasi mas madali pag gumagamit tayo ng differentials. So ano nga ba ulit yung differentials? So DH and DA, there's a formula for that. So halimbawa yung DH, DH is equal to the partial derivative of H with respect to X times dx plus the partial derivative of H with respect to Y times dy. Okay? Exercise na lang na yan yung partial derivatives natin. Alright? So, kapag tinignan natin yung absolute value of DH, okay, by triangle inequality, less than or equal yan sa absolute value ng part na ito. No? So, less than or equal siya sa absolute value ng first term plus the absolute value of the second term. That's triangle inequality. So, kung yung, balik tayo dito . So, kung yung value mo ng x and y are 3 and 4 respectively, tapos yung dx and dy, remember those are the change in the input. So, yung change in input natin ay plus minus 0.05 each. Okay. So, yan, x, y, tapos dx and dy. Mako-compute na natin yung bounds for dh. Okay. So, dh is less than or equal to absolute value of 3, square root of 3 squared plus 4 squared. Tapos dito, ang absolute value ng dx ay 0.05. Same here. So, palitan mo yan ng 4, tapos 0.05, and then this denominator. And then just calculate. Pag kinalculate nyo, lalabas ay 0.07. So, yung change in yung error natin in computing for the length of the hypotenuse, at most 0.07. Hindi ganun kalaki yung error, no? 0.07 lang. So the true hypotenuse, okay? So yung true length ng hypotenuse, ano bang na-calculate na hypotenuse kung ang x natin ay 3 at y ay 4? So kung x ay 3 at y ay 4, ang mako-compute nating hypotenuse ay 5, na 3, 4, 5. So yung true hypotenuse, sabi dito, between something like 5 minus 0.07, so that's 4.93 and 5.07. So, di natin alam kung yung totoong hypotenuse, but it's somewhere in that interval. No? Alam na natin na nandyan lang siya. So that's very nice. Same with the area. So again, ma-estimate natin yung error dun sa computed area versus the true area by computing for this differential dA. And yung coefficient ng dx, that's the partial derivative with respect to x. Na? So x here is so we have here the partial derivative is 1/2 y, na tama. And then this is the partial derivative with respect to y, so 1/2 x. And same here, triangle inequality. So we get this. Tapos same values ng y, dx, x, and dy as before. Ang lalabas ay, no? So ito 3, 4, 0.05, 0.05. Ang lalabas ay 0.175. So yung maximum possible error in the computed area is approximately 0.175 cm squared. So again, kung yung according to our measurements, yung x natin ay 3, yung y ay 4, so yung makukuha nating area ay 6. Na? Pero sabi dito, pwedeng hindi talaga 6 yung area ng triangle. No? Pero the true area is somewhere between 6 minus 0.175 and 6 plus 0.175. So again, hindi ganun kalaki yung error. Okay. So the concept of differentials, you can extend it to a function of n variables. Okay. So if you have a differentiable function of x1 up to xn, okay, then du is defined similarly this way. Use yung mga partial derivative, i-multiply mo ng mga corresponding differentials. Tapos, pwede mo rin siyang gamitin sa application. If you just let the xi represent the change in the value of xi, yung du will represent an approximation for the actual change in the function value. Okay. So for this video, ang ginawa natin, dinefine natin yung differential, and we showed how we can use it, or how we can use them to approximate a variety of things.